All right, guys, so now that we know how to deal with addition, subtraction, multiplication, and division with our inequalities, we are moving straight into multi-step because other than flipping your sign when you're multiplying or dividing by a negative, these are just like equations, and we just did a whole bunch of equations. So the steps are basically the same. Step one is to distribute if you have any parentheses, so you don't always have to do that, only when you have parentheses. Step two is to combine like terms, get your x's together, get your constants together, and then step three is to solve for x. So after you combine like terms, typically you have a two-step left to finish out. Sometimes it's only one step. So let's just hop in to some examples. So here I'm going to draw my line down. And I have variables on both sides, so I want to get them together on the same side, and I like to move the smaller. The smaller in this case is negative 6n, because that is smaller than negative 2n, so I'm going to do the opposite and add 6n to both sides. So then we have 13 is less than or equal to 49 plus 4n. And now we have a two-step to finish out. So I'm going to subtract 49 from both sides, which I believe is negative 36. And then we will divide by 4 on both sides. And I'm dividing by a positive, so I do not have to flip my sign. So I have negative 9 is less than or equal to n, or n is greater than or equal to negative 9. If you prefer your variable on the left-hand side, if that's easier for you to think of. All right, second example here, I have parentheses. The very first thing I want to do is distribute. So that's going to give me 2x plus 8. And then I want to combine like terms at step 2. So I can combine 3 and 8 because they are both constants. That means they don't have a variable. And now I have a two-step to finish out. So I'm going to subtract 11 from both sides. And then I'm going to divide by 2 on both sides. And at no point did I multiply or divide by a negative. This is a positive. It doesn't matter that 8 is negative. So I get x is greater than negative 4. All right, so there's those two. We're going to also practice, I know last week we talked about writing these, we're going to continue practicing that. Here it says 1/2 of a number increased by 9 is less than 33. So 1/2 of a number, we're going to use n for number. So 1/2 n increased by 9 means we're going to add 9 is less than 33. So that's how we turn it into a inequality from our number sentence. So then from here, we just need to solve. We're going to subtract 9. We have 1/2 n is less than 24. And then we will multiply by 2 over 1 to get rid of that fraction, which is the same as 2. So then you get n is less than 48. Okay, so that means any number smaller than 48 would make this true. If I take half of 48 and add, well, not including 48. So if I take half of 46, that's 23 plus 9, 32 is still less than 33. So there are a lot of answers here. But they all have to be smaller than 48. The sum, so sum means we're adding, of twice a number and 5, so twice a number would be 2n, and 5, is no less than 15. So no less than means we're doing the opposite of less than or greater than 15. And then we can solve this. So we will subtract 5 from both sides and divide by 2 on both sides. So n, anything larger than 5 would make this true. So let's say we plug in 6. 2 times 6 is 12. 12 plus 5 is 17. 17 is bigger than 15. There's a lot of different answers, but they all have to be bigger than 5. All right. Remember when we were doing variables on both sides for equations, there was always 3 potential outcomes. So the first one is normal, one solution. So we consider that to be like any of the 4 we've done so far today. Those all have one solution. There is a final variable, inequality, and a number. All right. So like if I tend to try to solve this one and I divide by 2 on both sides, I get a solution. Anything larger than -2 is my solution. You could also get infinitely many solutions. So this happens normally when we have variables on both sides that are exactly the same. So these are both a positive 1x, meaning when I try to subtract them, they cancel out. But for this one, we just have to check if it's true. 8 is less than 11. That's true. So that means we have infinitely many solutions. Every single solution you can come up with works. All of them. All right. Now for no solution, if I try to subtract x from both sides, we get 6 is greater than or equal to 13. That's false. 6 is not bigger than 13. So that means you have no solutions. Absolutely nothing works. So if you remember back to equations, infinitely many was something like 5 equals 5 because that's true. Here, it can be anything that's true, so there's more possibilities. 8 is less than 11. No solution when we are talking about equalities would be something like 5 does not equal 6 because that's not true. But in this inequality, you just have to ask yourself if it's true. So 6 is not greater than 13. That's why we said that was false. All right. So that is what infinitely many and no solutions look like in an inequality. So we'll do a couple examples of that now. Here we have 5n plus 1 is less than -2n plus 6. So I want to get my variables on the same side. I'm going to choose to add 2n to both sides. So we get 7n plus 1 is less than -6. And then we can subtract 1 and divide by 7. And I'm dividing by a positive here, so there's no need to flip. All right. Okay, so I want to try to get my x's together, and they're the same. So if I subtract x, it's going to cancel it from both sides. 5 is greater than or equal to 3, so this means we have infinitely many solutions. Every single solution you can come up with, like let's say we pick 3, will work. 3 plus 5 is 8, 3 plus 3 is 6, 8 is greater than or equal to 6. Everything works. All right. On this one, the first thing we want to do is distribute. So you have 10 minus 5n is greater than or equal to 3n minus 6. And then we will continue solving. So I'm going to add 5n to both sides. So you get 10 is greater than or equal to 8n minus 6. And then you'll add 6 to both sides. 16. And then divide by 8 on both sides. You get 2 is greater than or equal to n. Or if you prefer your n on the left, you can flip it around. All right, last question. For what values of x is the area of a rectangle greater than the perimeter? So first, area of a rectangle is length times width. Perimeter is 2 lengths plus 2 widths. Okay, hopefully you know those formulas just from your past experience. So it says area is greater than the perimeter. So if I take my length times my width here, I'd have 7 times x plus 2. And they want that to be greater than the perimeter. So then you have 2 times x plus 2 plus 2 times 7. And this is what we're solving. So we have to distribute first to get rid of those parentheses. It's got 3 sets, or just 2 sets here. So 7x plus 14 is greater than 2x plus 4. And then 2 times 7 is 14. Now we can combine like terms. So that would give us 2x plus 18 on the right. And now I'm going to get my x's together. So I'm going to choose to subtract 2x from both sides. That's going to give us 5x. Then we can subtract 14 from both sides. So you got 5x is greater than 4. And then we'll divide by 5 to finish this out. So x is greater than 4/5. Any value of x larger than 4/5 will make the area greater than the perimeter. All right. Anything 4/5 or below is going to do the opposite. Okay, so let's say I plug in 1 because 1 is bigger than 4/5. That would make this a 3. 3 times 7 is 21. 21 is greater than if I added them all together. If I take 7 plus 7, 3, and 3, that would give me 20. 21 is larger than 20. All right, that's the end of your notes for today. You do have a big ideas assignment.